Okay, this is the first topic of our AS2 mechanics. But we're going to be looking at kinematics, which is the study of motion. But before we do that, we're just going to look at a couple of concepts in mechanics. So we'll look just down to these. So we will use what's called mathematical modeling. So this is where you basically simplify a real life situation so that you can apply the basic mathematics that you have. In reality, there's a lot of things which are going to be more complicated than they are. So there's a couple of assumptions that we're going to be making throughout this course. So in general, if you've got a string, it is light or it is weightless, you could say. A smooth surface is one with no friction. Air resistance, more often than not, is ignored unless I tell you otherwise. A particle is something without size or shape, so it has mass concentrated at a point, and that means it doesn't matter where you touch it, it will not make a difference. A thin wire has no thickness. And what else we got? A thin wire has no thickness. A string is inextensible, so it doesn't stretch. And a bead is a particle that has a hole through it, and the tension in the string on either of the sides would be equal. And gravity always acts vertically downwards and is rounded to 9.8 meters per second squared. Sometimes I'll tell you otherwise. Okay, so there's a few standard things that we need to know. Okay, we're going to look at units, and units we're going to use what's called the SI units, the Standard International System. And three basic quantities are that mass is measured in kilograms, length is measured meters, and time is in seconds. So you've got to be consistent with your units. So for example, if your speed is in meters per second in a question, your distance needs to be in meters, your time needs to be in seconds. So we're going to look at 4 wee examples here and how we convert the following to SI units. So the first one was 19 kilometers. We want to convert that into meters. Really easy. Multiply by 1,000 to give you 19,000 meters. Your second one is 16 kilometers per hour. So 16 kilometers per hour, then you could just change that. I'll convert it into meters per hour first. Meters per hour by multiplying by 1,000. So I'm going to go 16,000 meters per hour. Okay, and then I have my 16,000. If I get that in the meters per minute, you would go 60 times less. So 60 has to go on the bottom line. And if I wanted to convert it into seconds, then I have a 60 to get it down to my minutes, and then another 60 to get it down to seconds. And if I did that, let me just check, 16,000 divided by 60 and then divided by 60 again was going to be 4 and 4/9, which is the same as 4.44 meters per second to 2 decimal places. Okay, part C, we had 3 meters, and it says minute, m to the minus 1, minute to the minus 1. So the way I would write that, by the way, this is just my preferred way of writing it, is meters per minute. Some people prefer the other one, that's entirely up to you. But I want to get that into seconds. So if I go 3 meters per minute, then that is going to be the same then. 3 meters per minute. If I only go in 1 second to get it into seconds, I'd have to divide by 60. So if you did 3 divided by 60, you're going to get, and that's a nice decimal, 0.05 meters per second. And the last one, part D, what was it? 8 grams per centimeter squared. 8 grams per centimeter squared. Again, I'm going to write that just as 8g per centimeter squared. Okay, right, converting between area and volume are both both tricky things to do. The first thing I'm going to do, if you imagine there's 1 centimeter squared, so that's 1 centimeter by 1 centimeter. If you imagine you blew that up to be 1 meter squared, you're going to have to multiply by 100 there. There's 100 more in that direction and 100 more centimeters in that direction. So to get from here to here, there's actually going to be 100 times 100, or 100 squared more. That's how much bigger the area is. So if you have 8 grams per centimeter squared, you would multiply that by 100 squared to get it into grams per meter squared. Let's just do that. You can change the order you do these things, by the way. I'll show you what I mean in a second. So that's going to be 80,000 grams per meter squared. And then if you want to convert that into kilograms, you divide by 1000. So it's just going to be 80 kilograms per meter squared. And that's it. Okay, just to show you that question, what was it? 8 grams per centimeter squared. You could have converted first into kilograms by dividing by 1000. So 8 divided by 1000. And that's going to be 0.008 kilograms per centimeter squared. And then do your 0.008 times 100 squared to give you your grams per centimeter squared. And again, that would give you 80 kilograms per kilograms, sorry, that should have been meter squared, kilograms per meter squared. So you can see it will do the same thing.